Hi class. Today we're going to look at proofs, specifically algebra proofs. And in algebra proofs, this is the problem that we're going to have at the beginning. We're going to have a given and we're going to be asked to prove some statement. Now in algebra proofs, that means that I'm going from this original top equation to see if I can prove that this and this are the same. So if I solve this one, I will get x equals 3. So I just basically take my original problem, solve it, and justify my steps so that I can say that I have proved, using my reasons and my statements, that my original equation equals x. My original equation gives me x equals 3. So for my algebraic proof reasons, I'm going to go through some of these that are going to be our most common algebraic proof reasons. These are the ones that we're going to need to know for this class. The first one is going to be the addition property of equalities. This is going to be the reason why we can either add or subtract from both sides of an equation. Then we have the multiplication property of equalities. This is the reason why we can multiply or divide from both sides of the equation. Now I want to make sure that you're actually writing these down. Unfortunately, I didn't put a space for them in our packet, but you can have, but you can just put these on a separate sheet of paper. And then we have the symmetric property of equalities, used when you need to change the order of something, like x equals 2 or 2 equals x. If I need to flip something around from x equals 2 to 2 equals x, or vice versa, I can use the symmetric property of equalities to do that, because those mean the same thing. The distributive property, used when distributing my numbers, so I'm going to take my 3 and distribute it to both terms on the inside, or I could use the distributive property when I'm factoring. So if I need to bring out a 2 out of both the 2x and the negative 4, I'm going to divide both of those and factor out a 2. So let's go ahead and try our first proof, algebraic proof, together. So I'm given this equation here, 6x plus 2 times the quantity x minus 1 equals 30, and I want to prove that all of this is the same as x equals 4. So I'm going to start out my statements always with what I'm given. So every time I'm given a proof, my given is going to plop right down here in my first step, and my reason is always going to be given. Okay, this is basically me pulling in the problem into my proof. So now I know that you guys have been familiar with algebra at this point. A lot of times there's multiple ways that you can start, or multiple orders that you can do, either moving your variables to one side first or moving your constants to one side first. So you would not necessarily end up with the same order of steps going from top to bottom, and that's okay. As long as you end up getting from the top part to the bottom part correctly in whatever order you choose, like I said, as long as it's a correct order, as long as you're doing something that is sound math, it'll be fine if it's in a different order. So here I chose to go ahead and distribute my 2 into my x and my -1 to get this step, so I used my distributive property as my reasoning here. And then I ended up, what did I do here? I ended up adding like terms or combining like terms to get my 6x and my 2x to become 8x. So I put my reasoning as combining like terms. And then I took and added my 2 to both sides. So I was basically moving my 2 from the left side to the right side to get all my constants together. And that was the addition property of equalities. Finally, I ended up dividing 8 on both sides, and that is the multiplication property of equalities, because, like I said up here, we use the multiplication property of equalities as the reason why we can multiply or divide from both sides. Basically, I can multiply by a fraction, which would be the same as dividing by a whole number. So this one property covers both of those. Same thing with the addition. I would use the addition property of equalities for both addition and subtraction, because I could technically be adding a negative number, so I don't need to have 2 different properties for the addition, and I don't need 2 for the multiplication. So this is what my proof looks like in the end. So we'll do one more together, and then there are going to be a couple of proofs in your proof packet that I would like for you guys to do on your own after, let's see, is it just one more? Yeah, after this one. So here I am given 4x plus 6 over 2 equals 9. Again, I always start out with the problem that I am given. So in this case, in this problem here, I end up multiplying by 2 in order to complete my first step. And I really do need to multiply by 2 before I do anything else, because this division by 2, or this fraction bar here, is acting as a grouping symbol. Kind of like if I had a 2 out front here with parentheses, I would have to take care of the 2 first before I did anything else. So I can multiply by 2 on both sides, and I get 4x plus 6, which is my numerator, because the 2's just became 2 multiplying by 2 and dividing by 2, those 2 cancel or just become 1 multiplied on this side. And 9 times 2 is 18. And the reasoning for that would be the multiplication property of equalities. And then for my next step, I ended up subtracting 6 from both sides, which again, I am going to, I don't know why I can't get rid of that. Here it goes. That is just going to be the addition property of equalities, because that works for both adding and subtracting. And then finally, I ended up dividing by 4 on both sides, and that gave me, and the reasoning for that is the multiplication property of equalities, and that gave me my final answer, which is what I was trying to prove, is that this statement, or this equation up here, leads us to the conclusion that x equals 3 in the end. So this is a full proof going from my given to my proof statement using reasoning along the way. So there are going to be, let's see, 2 algebra proofs in your proof notes that I want you to go ahead and try on your own. So you're going to have your given as your first statement and your prove as your last statement. Now you can do this equation in multiple different ways, so you don't necessarily have to have 5 steps in your proof. That's just how many steps it took me to solve this problem. If it takes you more, that's fine. And again, down here, this is the originals, the given, so that goes in that first spot, and then your proof statement, what you're trying to prove, is going to be in your last spot. And then, of course, it may not take you 4 steps. Maybe it'll take you 5 or 6 steps to solve the same equation, and that's fine. However it works out for you, you just need to make sure that you have your reasons to justify what you're doing in your proof. So I'm going to leave these up here for just a second. If you need to pause the video to write down the problems because you don't have your packet yet, make sure you try these before our Google Meet. Have a great afternoon.